Hello guys, it's Math with John. I got, I believe, problem 3 for the Teach Me videos for today's week. So yeah, it's already week 9, so let's do this. So what problem do I have? Problem 3 says, find all inflections values and inflection points of the given function and then find the regions where the function is concave down, find all the inflection values and the inflection points using the second derivative, and then show your inflection values and inflection points are true by using decimals. Make sure the graph function and the points of g of x equals x to the power 4 plus 8x cubed plus ax squared. So let's do this. So go into my notes. I don't know what's better. You think if I do it like this, guys? I typically like real paper. I don't think there's a replacement for real paper, but that's fine. We're gonna use phone because it just uploads easier, and I care about you guys. I want you guys to have a good quality video. You know what I mean? Otherwise, it's better for me when I use real paper, but for you guys. Okay, so let's go. We got g of x equals x to the 4th plus 8x cubed plus 18x squared. You see, so first thing we're gonna do, we're gonna find g prime of x. Well, what is g prime of x? If you guys don't know, well, g prime of x is pretty much just taking the derivative of this right here, this. So how do we take the derivative? You could use the long derivative formula, if you guys remember it. Let me show you the derivative formula. So the derivative formula. Okay, so it's this. So one way to express it, I don't know what color would be best. Maybe red. You could express as f prime of x, or it doesn't matter because in this, what's the heck's going on? What is it doing? I have a weird pen. Okay, let's go with that one. I think that was like a straight. Now it doesn't delete. F prime, or in this case we have g prime of x, so I'll just make g prime of x. It doesn't really matter. If it was f of x, it would be, so we have g prime of x and then equals limit of h approaching 0, and then g of x plus h minus g of x all over h. Well, luckily, guys, we don't have to do that. We have the power rule. So what is the power rule? The beauty of it? Well, the power rule implies, here, let me make it, I don't know what's another bright color. Oh, maybe yellow? Is that easy to see? Power rule implies d over d of x, and then we get the x to the power n. So this is the power rule. D over d of x is just a fancy way of saying taking the derivative, and we have nx n minus 1. Okay, so I love the power rule, so we're gonna use that. I think this one is just good to know, but it's kind of too long, so that's why I'm just gonna use the power rule. But I think it's good to learn it, to understand it. So if we take g prime of x equals, so we're not multiplying, we're using this. So if we subtract, so what is 4? 4 minus 1 This equals 3. And then we moved it n, so we get 4x to the power 3. Then plus, and the same thing I'm going to do. Same exact thing. So here, let me erase that. And then if we do 3 minus 1 equals 2, right? I feel like I'm doing a little bit too much. Just don't know how much, what's a good balance. And same exact thing. Then, in essence, yes, we are multiplying, but it's the power rule. And it's going to be 24x to the power of 2. Then plus, here, I'm going to actually erase that. So I have space, x squared plus, and then same exact thing. 2 minus 1 is 1, and then multiply, and we get 36, right? 36x. My brain froze for a second. Yeah. But then we're gonna get the g double prime of x. Well, don't be scared that it's g double prime of x. All that is just we're taking the derivative of the derivative. It's kind of cool. Kind of reminds me of, like, if you ever seen like these photos of, like, I'll show you guys what I'm talking about. Kind of reminds me of, you have a drawing, and then inside the drawing you have another drawing, if you get what I mean. So that's how my brain thinks of it. I don't know, but it's not really like that. Okay, so back to math. G double prime of x. So second derivative, same exact thing, using the power rule. It's going to be 12 now. X squared plus, and then what do we get? 48x. You see, using power rule. And then it's a constant, so then let's just be ups. My bad. Yeah, so then we could see that this is a constant, so it's just gonna be 36. Well, what's a good way to rewrite it? We could rewrite it as g double prime of x equals 12x squared plus 48x plus 36 equals 0, because that's the constant that we got. We know that the 0 is undefined. Now we could simplify, because we do have a quadratic equation, if you guys see it. Do you guys see it? Or you don't? I'll help you. So x squared plus 4x plus 3. You see what I'm talking about? That equals 0. That's the quadratic equation. This is what I was talking about right here. Quadratic. Okay. So quadratic equation, x plus 3 and x plus 1. Okay. Why does this work? It's because if you were to do the diamond method, same thing. So okay, let's keep going. So after that, we know that, like, look, the inflections are x equals -3 and x -1, because at those points it's gonna be 0. Now what we could do is, okay guys, so I finally got Desmos working on my phone. It's kind of hard, I'm not used to it, but okay, this is part 2 where I showed the Desmos part. Okay, so we had original function, which was g of x equals x to the power of 4 plus 8x cubed plus 18x squared. Okay, but then if you want to check, we could put in these inflection points. Inflection points were essentially just, it's a fancy way of saying the points where it makes it 0. And if we look at the graph, we can see between these points, we can see how it begins to bend downwards, indicating that the, man, I don't know how to move that well or zoom in. There you go. It's kind of hard on the phone. Indicating that the concave is going down or down.